afternoon. Glad to have everyone here today. This is webinar 292. Today, our topic is Winter Program Series regarding STEM program selection. Before we start, I'll just give you a little more information about Harmony Plus. As you may know, we are located in the Silicon Valley area in Mountain View. Harmony Plus is an international learning ecosystem, and we are determined to upgrade education through a hybrid learning model that leverages both in-person and online resources. Harmony Plus is equipping students with different kinds of skills they need to adapt and excel in a highly competitive professional climate. In our hybrid learning platform, we have education services that are online and offline, synchronous and asynchronous, that combine both theory and practice. We offer guidance from top teachers, endorsement from leading universities, build competitive advantages, and enjoy continuous improvement together with students. In past years, we have helped students to get admitted to top-tier schools such as Johns Hopkins, UCLA, Stanford, Yale, and more. Our students enjoy and find much happiness and adventure through all of our programming, both in terms of future learning packages as well as online learning courses. I'll talk a little bit more about our service offerings later, but let's spend more time firstly with our guest today, Dr. James S. And Dr. James S. is a professor of data science and machine learning at UC Berkeley. And he's going to take us through quite a bit of interesting information about STEM programs. So without any further delay, let's now switch over to Dr. James.
All right, great. Thank you, Andy. And just a sound check here. I'm sorry, my video is off as well, just make sure. All right, thank you, Andy, for the introduction here. And welcome, everybody. It's great to see you all here today and talk about STEM and talk about what we mean by STEM: science, technology, engineering, and mathematics. And you're not surprised to see that STEM is powering the future currently. And when we think about the future, we think of many great things, and artificial intelligence and machine learning come to the forefront of our minds as the core software that's driving and powering the present and the future. So today, I want to tell you about STEM and why it's important. And unfortunately, I think when we're going through school, kindergarten all the way through to high school, we learn lots of different things. And we learn things in a bottom-up fashion. And sometimes we wonder, why are we learning these things? These don't make sense. And I think today, I hope that I can connect some of the dots that you've already mastered and perfected and show you how they play into the future and why it's important to indulge and master those topics now so that they can be pillars or foundations that you can build future technologies upon. So I want to give you a sense of where I'm coming from first, because I always like to know where people come from. And so just to give you a kind of a sense of me, I'm from Ireland. I was born and raised as a farmer on the west coast of Ireland. And so for the first 20 years of my life, I was a farmer. And then I pivoted into computer science and business and artificial intelligence in particular. I had the opportunity to go work in Japan on AI. And in fact, my first job title was AI software engineer. And then I did a PhD in artificial intelligence and machine learning. And subsequently, I've lived in the US since 2001. And there I've done research, I've done development, so R&D, sometimes big R and big D, and sometimes little r and big D. And so I spent a while at a spin-off from Carnegie Mellon University in Pittsburgh before making my way to the West Coast here about 2005. And I have had a variety of opportunities here to take my STEM background and apply it to real world problems using artificial intelligence and data science. So out here in the West Coast, I teach at UC Berkeley. I also run a small company, consultancy company here in San Francisco, and I consult with Fortune 500 companies all the way down to smaller startups. So Fortune 500 companies include AT&T, Target, and a plethora of other household names that you would be familiar with. So so one of the things that has become very clear to me is that anything is possible. So when I was going to school, people told me, focus on math, study hard, and it'll stand you in good stead. I'm going to tell you the same thing today. And so here's how I would summarize all of that. So, so for me, I've been working in this area for 30 years. Okay, fair enough. But the important things here, this is a Venn diagram, just in case you hadn't noticed. So I get a sense that you use Venn diagrams a lot. It's a great tool for communicating ideas and summarizing various concepts. And so here I'm going to use this to summarize the skills that I think are important. And you'll see that some of these naturally intersect with STEM. So the first thing is that the first bucket of skills here is math and theory. So it's going to be important for us to understand fundamentals. I'll show you later some of the fundamentals that you've already learned and maybe haven't figured out why did I learn those things. And I'll show you that these are foundational and critical to artificial intelligence and machine learning. So when we think about theory, we think about math, we're thinking about fundamental concepts. And they range from the equation of a line, the distance to a hyperplane, calculus, the chain rule of calculus, and many other basic concepts. And if we get those down, then everything else becomes really easy. And so this is our first skill set here. And you'll see that that falls in line with mathematics and engineering, and also maybe some science. So in addition to this, we want to be able to program the computer. Being able to programmatically express things and solve them using a computer is a very important skill these days. And so here we want to learn how to program a computer, what is a programming language, what's the fundamentals like object-oriented programming, different styles of programming, and so on. And we want to be able to write code. Not only that, we want to be able to debug code. We want to be able to interpret code. It's already written by other people. And so these are just two important skill sets that really are core to STEM. And hopefully you've already started to spend time in this bubble and in this bubble here also. Now, in addition, it's important to have some domain expertise, if possible. So that might be a long shot for us all so far, but maybe you have a skill. For example, you might be a great tennis player. So that's a domain, it's an expertise. You might be a master chess player. So, but going forward in your careers, you might become a master salesperson or a business person, or you might become a fantastic bioinformatic scientist. So domain expertise is another area where it's good to build fundamental skills and expertise. And so that's our third set. Now, there's also a fourth set here, which I think is important too. We need to be good at communications. And it's not like we have to be leaders or teachers and so on, but we need to be able to articulate where we are. And so sometimes these soft skills of communications are ignored. And I find that people find it difficult to talk about what they're doing, what they've done, problems they might be facing. And then also I find it interesting that people find it hard to work together in groups. And so, being in high school, being in kindergarten, we're kind of working in our own a lot. And the idea of working in a group or working on group projects is a little bit alien to a lot of us. So we need to perfect some of these skills. So these are 4 buckets of skills that I think are fundamental. And so during high school and university, I think that we can certainly work on math and theory. We can work on the technology side. We can work on the softer skills as well. And then domain expertise will probably come naturally as you embark on your careers via internships and positions you might take up in an organization. So I can imagine he's got this famous quote: "The world's first trillionaire is the person who masters AI." And I have a question for those of you in the audience today. Who wants to be a trillionaire? Maybe you could, can we have a little show of hands here, maybe, to see who wants to be a trillionaire? Maybe you can raise your hand virtually on Zoom here. So far, I only see one person who wants to be a trillionaire. Oh, two people. Any advances on two? Oh, we're not ambitious here. So I think what I'm seeing here is people who are a little bit shy and lack on the communication leadership skills here. So don't be afraid to articulate here whether you want to be a billionaire, a trillionaire, sorry, or not. So take every opportunity to communicate. And I'm a big believer in over communication. So in addition to your STEM skills, communication is key. And I think that if you listen to people like Warren Buffett, he'll tell you the same thing. I'm not sure if you know Warren Buffett. He's also a very successful business person and investor also. But his belief is that communication is the kind of skill that separates the really successful people and the successful people. So just bear that in mind. So, some people will ask me, they say, Jimmy, look, is it really worth me getting a college degree? Is it worth getting a PhD and so on? And I'm not going to defend getting a PhD or a master's or an undergraduate degree. I'm just going to show you the numbers here. So, if we look at our a lifespan, we can see a career lasting about 40 years. That's 40 years. And if you graduate high school, or maybe not, and that's it in terms of formal education, then your lifetime value, your LTV, or your earning power, will be about $1 million over a career span of 40 years. So that's about $25,000 a year in terms of salary. Now, if you get a 4-year degree, you can double that. And so this is kind of the median income expectation directions like that. You can expect to get about 6 million. That's about 6x. And these numbers are based on data from collected in the US over the last couple of years. So, so what this is saying to you is that STEM is important. Not only that, but your earning power, earning potential is also significantly boosted if you pursue careers that really leverage STEM. So you can have a 6x earning power potential here over other maybe career or paths that you might take. So money is important, okay? But look, pursue your passion. I have taught a lot of different students. I have managed and led different teams in different organizations. And I will tell you that a grain of passion is worth a ton of hard work. And it's important for us to find something that we're excited about. And so if you're passionate about something, in my experience, there's not anything too much I can ask for of a person who is passionate about their work. They will go above and beyond the call of duty. They are working because they're enjoying it. And sometimes, when I teach, it's a labor of love more than making money. And that's kind of the passion that we're looking for. So in addition to your STEM and communication skills, well, add that passion component as well. So find out what you're passionate about. And it might be, sometimes figuring out what you're passionate about takes time. So maybe you haven't figured it out yet, but just then keep an open eye, and you might be surprised when that passion just pops up. I want to just kind of tell you about some of the machine learning, because machine learning combines technology, combines science, it combines math as well. And I kind of want to kind of talk about tic-tac-toe. It's a game that I guess we've all played or should have played by now in our careers. And when we look at tic-tac-toe, it's a pretty simple game, it seems, and pretty innocuous. And if this is the state of the board here, I can lay out future possible states of the board depending on different moves that we make. If I make a if I make a move here, I can take this state of the board and bring it to here. And so what I have here is kind of a collection of states, future states, current states, and so on. And so ultimately, I can get to a winning state where I get 3 items in a row, 3 X's or 3 O's in a row, and that's my desired goal. So now, if I asked you to come up with a rule base or a set of rules that I could apply to the current board that would allow me to never lose and win, I guess, could you do that? And so if I give you a few minutes, I'm sure you might come up with something like this. This is a rule base here. If someone has a threat that is 2 items in a row, then take the remaining square. So that's one rule. Else if, so here's our 6 rules. And if I follow these 6 rules, I am never going to lose, and then potentially I'm going to win. So we call this an expert system. Now, I could view you all as experts or individually or collectively. And so you might come up with this rule base. So back 20 or 30 years ago, we would talk to experts in various domains, not just in tic-tac-toe, but in other areas as well, and say, hey, give us the rule base for how to be successful in this domain. And that was an interesting way to build systems from scratch. You would talk to experts, they would give you the rules, and then you could follow them. But unfortunately, this expertise keeps changing. And so therefore we'd have to keep updating our software, our rules, and so on. And it was very cumbersome and not scalable over time. So this is kind of what I asked you to do. I asked you to study the problem, tic-tac-toe, then I asked you to write some rules, then you evaluate the rules and see, are they good enough? If they are, we launched our rule base. Otherwise, we go back and analyze the errors and try to correct the rules. So this is a typical way to solve problems back in the 80s, early 90s, and but it wasn't sustainable. And so we came up with lots of different useful systems, both in medicine and other disciplines, but unfortunately it wasn't sustainable, and it was encyclopedic in nature and always changing. So as a result of this inadequacy of expert systems, we turn to statistics, to math, and to machine learning to learn from data. So rather than learning from experts, we said, look, we've got lots of data out here. Can we leverage that data to build a similar rule base? And this is what we call machine learning. And so again, we study the problem, we gather data, and then we train a machine learning system. And then again, of course, we evaluate our system. And if we're happy, we launch. Otherwise, we go back and analyze the errors and maybe try to regroup and correct those errors. So this is machine learning, basically. And the kind of things we can do with machine learning today are just amazing. It's not just classifying images of cats versus dogs. Here are examples of cats images. Here are examples of dogs. And actually, we can build a classifier that can take these images and distinguish cats versus dogs class. In addition, we can build systems that can predict the price of a house. And so we can use features like the size of the house, the number of rooms, the amount of crime in the zip code, amongst many other pieces of information to estimate the price of a house in a neighborhood. So we can do lots of really interesting things with the machine learning. So sometimes students ask me, and people, like, it's just amazing sometimes. People think like data science and AI are the same thing. And, at a high level, at maybe 50,000 feet, maybe it all seems the same. And so I just want to kind of take a moment here to digress. And again, I'm going to use the Venn diagram. In this case here, the components of the Venn diagram are not circles, but they're squares. But over here on the left, I've got this kind of transaction-oriented data. So let's say I'm a major online retailer like Amazon. Then I've got data such as purchases, I've got returns, I've got add to cart, delete from shopping cart, browsing a page, and so on. These are all events or transactions that I can log and leverage. And so if I take that transactional type data, then I can build out different systems that can be of use to the retailer and to the consumer alike. And so one of those systems could be a personalization system, where when you show up to the app to go shopping, I can personalize that experience for you. And I can personalize which items are shown to you in response to a query that you might have. And so we call this more like data science, because we're using this transactional data, and the types of pipelines that we're building here can be built offline and deployed, and can be used real time to give you responses to your information needs or queries and so on. Now, in contrast, I have an AI system over here, which is more like a robot, where there's real-time data coming in from different sensors. And this sensor data is very different to the transactional data that we have over here. So the sensor data might be photographs from cameras. It could be LiDAR depth maps. It could be radar. It could be map data, latitude, longitude, and more precise HD map information. So there's a lot of information here that's streaming in real time, and we need to make decisions real time. So in actual fact, if I have a self-driving car, I need to be making decisions every 1/30th of a second. So 30 times a second, I have to make a decision. Do I accelerate more? Do I maintain speed? Do I brake? Do I turn on the turn signal? Do I change the steering wheel angle? So these are all actions I can take, or can I apply the brake? And so I have to make decisions 30 times a second with regards to the environment in which I'm in. So if I'm on a road, or if I'm on a highway, there's different decisions I need to make, and they have to be done real time with super rich sensor data. So this is an AI system, and as you can see, the types of data I'm working with are very big data, very rich, and so we call this AI. So versus data science here, which is based on transactional data. And in the middle here, there's a high degree of overlap, because the tools we use to solve both problems are similar, but yet the results are very different. We're using machine learning. Of course, we're using programming languages like Python, for example. We're using deep learning. And so that's why you have these overlapping sets here when it comes to artificial intelligence and data science. So like I mentioned, when it comes to AI systems, we're always sensing and perceiving the world, and then we're taking that sensor data and we're going to reason over it and try to take what we recognize, like a car in front of me. I recognize the lane, and then I start to reason and plan, because maybe I'm driving a car, but I want to go from San Francisco to Cupertino, and I need to make sure that we're tracking that whole experience, and I'm reasoning and planning about my current position, and so then we have an actuation loop that takes decisions. Not only takes, it takes the decisions that were made here and realize applying the brake or turn signal and so on. Like I said, this whole these three steps are repeated 30 to 60 times per second. Here's an example of the kind of processing that happens behind the scenes. So here we're recognizing a car, we'll have a distance, we'll have positioning information, we'll know which lanes are there, barrier, and so on. And this is just another example of perception here. And so all of this processing here is done using machine learning, deep learning, and AI techniques. So we have many different types of machine learning, but the common one that we use a lot is based upon supervised machine learning. And this is kind of the cats and dogs example. And I want to show you this example a bit more in detail because you know, the math you've covered already in kindergarten and high school will come into really big use here. So here's my cats and dogs. I got examples of images, and I can take this image and I can pass it through a machine learned model. It's called a black box for now, and it comes out and says, hey, that's a dog. Great. How does that work? Well, simply it's a line that separates these examples. So here I've just represented the image in 2 dimensions. Let's say I just took 2 pixels, random pixels here, x1 and x2. Normally I'm going to have hundreds, thousands of pixels that I will use, but just for illustrative purpose, I'm just picking 2 pixels here. And then we might see that this is one image of a cat, another image of a cat, and so on. And we've got images of a dog here. And in this case here, we can trivially draw a line between the 2 different classes and separate the 2 classes on these 2 dimensions here, and you get out the likelihood of this image here is 99%. It's a dog. So this is a linear classifier, and sometimes this is a very trivial example here, but typically we can't solve things with just one hyperplane. We'll be using lots of hyperplanes and to solve this. And so a similar scenario approach can be used to separate things like spam versus ham email. You probably have received lots of spam in your life so far. And okay, so when it comes to, again, the whole thing here is STEM is fueling modern day companies, organizations, and products. And so if we look at, we'll see that it is very much being used in healthcare, finance, retail, government, energy, transportation, and also in industrial sectors as well, and many other places like in consumer-related products and so on. So here's where we're at. We're in the 4th industrial revolution. If you probably have studied your history, and you know that the 1st industrial revolution was about power, steam, generated power, and so on. 2nd was more about assembly line back in the early 1900s, and then the most recent industrial revolution was the computer, internet, nuclear revolution in the 60s, 70s, and so on. And currently we are on the 4th industrial revolution, where we are really making a big leap into the future. In this 4th industrial revolution, we are fusing the physical world, the digital world, and biological worlds. And this is a big, bold, audacious leap forward for us. And here we're leveraging STEM in a big way. We have lots of computational platforms that can be used to store and manage data, to leverage that data to build out intelligent pipelines, like recognizing cars on the road and so on. And so these can be combined with lots of smart sensors, with 3D printing, quantum computing, and also around biological systems as well. And so this 4th industrial revolution we're actually living it currently. And it really will transform how we live, how we eat, what we eat, our lifestyles, how we work, how we learn even, and many other aspects of our existence and well-being. So this is an example of Flippy the burger from Los Angeles, and Flippy the burger can work for $3 an hour to make burgers in a very deterministic way. Here's another example of a robot in India greeting patients as they arrive in hospitals in India to check in. And this is just during COVID, as you may have noticed here. And So, if you listen to music, you probably might use Spotify. Well, Spotify is using AI to figure out what music that you have never heard of before that you might like. So maybe you've come across the Discover Weekly functionality on the Spotify app. If you haven't, go try it out. You'll be surprised that many tunes will be recommended for you that you've never heard of it before, and suddenly you'll be saying, wow, that's an interesting tune, and I may add that to my favorite list, and so on. So when it comes to interacting with computers today, we have these things called chatbots. And so you may have a smartphone, and you may talk to Siri, you may talk to Alexa. These are all examples of chatbots that not only answer questions for you, but they actually do things for you. They make calendar appointments. They may actually make a purchase for you, and so on. And so this whole area of understanding what I'm saying, despite my crazy accent, is all part of speech recognition, and it's being fueled by STEM also. So here's an example of a travel insurance bot where you can chat away and you'll get very intelligent answers. So believe it or not, AI is being used to generate screenplays. So I don't know if we have any people budding Hollywood stars here, but this is a short movie called Sunspring, which I encourage you to have a look at. It's about 10 minutes long. And the idea here is that the screenplay was generated using a computer. And it basically did this by digesting a lot of existing movie scripts that have been used in Hollywood and learning how to create a good script. So when we look at our phone, we can unlock it with your face. That's all based upon STEM. It's based upon artificial intelligence. And today I was just reading about Z9, this new camera from Nikon. And built into Nikon is computational photography. So computational photography is still very new, very embryonic, but yet they're using advanced deep learning and artificial intelligence systems for object detection and autofocusing, amongst many other things. So some of you may play golf, and so we have various sensors that can detect objects in a 3D world and tell us how far things are away from us and so on. So I want to just skip ahead here and, well, under the covers, we're using a variety of tools from Python. We're using various libraries from Python. We also use PyTorch and TensorFlow from deep learning and so on. And these are just some of the tools that we use to solve these problems. Now, gaming is a very big part of AI. And so recently, we've developed AI systems that can beat human experts at various games, including chess and Go. And I'm not sure if you've ever played Flappy, the board game here, but we can build systems that actually can be successful in this kind of nerdy, geeky type gaming world. And I want to tell you that, fundamental here is your STEM skills. We need to be able to take our technology, we need to take the mathematical skills, we need to be able to take the science and rigor that comes with science and solve it. So it all starts with numbers and matrices. We need to be able to do linear algebra. We need to be able to multiply a vector by a matrix, or take two matrices and multiply them out. And we can do this by hand, of course. We prefer to do it programmatically, and then here's an equation. You probably have seen these equations a lot and used them a lot, and you probably have taken a point x, y, plug it into this equation and see if you get 0. Well, did you know when you're doing that plugging in of the point into the equation here, all you're doing is calculating the perpendicular distance. And perpendicular distance, believe it or not, is just fundamental to machine learning. So here is our hyperplane, 3x plus 4y is equal to 12. Well, I can plug any point. If I plug it in 0, 0 here, I'm going to get a number, which is going to be -12. So minus 12 tells me that, so this hyperplane divides this universe into two half spaces. I'm going to have a positive half space and a negative half space. The positive half space means that if I pick a point over here and plug it into this equation here, I'm going to get a positive value. So I'll take away the equal sign here. I'll just put minus here instead. This is more, maybe a better way to look at things. And so if I plug in, say, 0, 4 into this equation here, I'm going to get 4, 4, 16 minus 12. I'm going to get a positive number. So any point in this positive half space here will give me a positive perpendicular distance. So straight away, you can see that I can use this phenomenon to partition this universe into two classes, a positive class and a negative class. And so when we think about cats and dogs, we think about one half space corresponding to dogs, another half space corresponding to cats. So this is a hyperplane. Hopefully you kind of recall this and understand what I'm saying here, but a fundamental notion that you've already studied. And we can study this, we can leverage this notion of a hyperplane extensively in machine learning. And it's a fundamental building block that's used not in archaic machine learning algorithms, but in state-of-the-art deep learning algorithms. I don't know, have you ever seen this equation before? Maybe again, a show of hands here. And let's kind of not be shy here in showing our hands here. Anybody heard of this equation before? Seen this equation before? Yes, we've got one, we've got a couple of brave people here. Come on, over communicate, guys. Raise your hands. Don't be shy. All right, cool. All right, we've got a couple of mathematicians in the audience. Excellent, excellent. Who are not shy, I should say. That's the other caveat here. So basically, you know, this equation here allows me to find the root of an equation. The root is the zero crossover point for a curve. So these are roots. So here -2 is a root here, and also 2. And I can recover this by plugging in this formula here. Sorry. So we can see that we can get A, B, and C here and plug them into this formula, and this will give us -2 and 2. Okay, so that's kind of very simple if we've got very simple equations here. Well, it turns out that finding the root of a function is fundamental to optimization theory. Optimization theory is the most important building block in machine learning and in artificial intelligence. And so Isaac Newton, maybe you've come across that guy, he introduced these notions of roots and how to use them in the context of optimization theory. So we use Newton's theory every day when we're doing machine learning and AI, and we're very grateful to it. So again, this equation here doesn't scale well in practice, but we kind of step it up and we use Newton's theory of for solving, trying to find the minimum of a function or a maximum of a function. So again, all of this stuff that you studied so far is not squandered. It's just leveraged. We're stepping on the shoulders of this stuff and moving forward in a big way. And so one more thing that comes to mind is here, you know, when we think about what's happening today, we hear things like machine learning, we hear about artificial intelligence, we hear about deep learning, we hear about bioinformatics, we hear lots of different things going on. And we think, oh, wow, these are all very exciting and new areas. Well, actually, if you look under the covers, the fundamentals haven't changed that much in the last 100 years. And so that's exciting. So what I'm trying to say here is invest in the fundamentals, invest in STEM, and your training right now in high school and beyond will stand you in good stead going forward. So let me see here what I want to say here to finish up here. So at Harmony Plus, and Andy will tell you more about this later, but we've got a variety of programs that we have available that will help you flesh out some of those skills more concretely. And some of the things that I work with, some of the courses are Introduction to Programming. It's important to be able to program, and it's also very important to take your time and learn those fundamentals and get comfortable with them. I know that when I started programming first, I was literally coming off the farm and trying to figure out how to use a computer and then dropped into the deep end in terms of programming. So I understand how difficult and challenging it can be to program. We also have a course on Python for data science and artificial intelligence, because at the end of the day, we're manipulating lots of different types of data. We need to be able to store that data. We need to be able to query it. We need to be able to filter it. And Python for data science and AI is another opportunity to refresh Python skills, but in the context of data and data management. So then we have a very popular course on powering artificial intelligence through machine learning. And that kind of, here we learn about machine learning and we learn about AI and how these tools can be used to solve a variety of problems. And some of the projects we engage in are, we build a chatbot from scratch. We build object recognition systems from scratch. We also have another course that's kind of popular as well, and that's gaming and AI. So as you can see, artificial intelligence can be used to build robotic games, robotic gaming agents to represent us and play chess and Go and many other fun games. So with that, I'd like to stop here and maybe take a couple questions if there are questions or comments or criticisms. And again, don't be shy.
I do have a couple of questions from the registration I could share to the screen.
Okay, great, thank you. And so if people
You're
are
gonna have
shy,
to unshare your screen first though.
okay, I'll stop sharing here. And in the meantime, if people have questions, maybe you can type them in the chat. We'll see them there. And okay, so the first question here, what are some computer science major activity benefits? Well, I think that I think I highlighted the fact that if you pursue a career in this area, you can potentially end up getting a job that's very satisfying, very challenging and rewarding. And financially, it can be really beneficial as well. So I'm not sure if this is the question, if this addresses the question adequately. So then the second question here is what are the requirements for students to participate in these programs? So I think that the big requirement is that you're passionate. I'd like to see passion, because passion trumps all other skills. But having said all that, I think that we have programs here at different levels that we highlighted. So you can start in at the beginner level, maybe say, oh, I'm a novice programmer, or I don't know anything about programming. We also have courses on fundamentals of mathematics and statistics. And then we have programs here on artificial intelligence and machine learning, and also data mining and other topics. And so we also have interesting applications where we say, look, how to build a gaming robot from scratch. And that's a hugely interesting, challenging course, but it's real fun because we actually get to work on real stuff. We build out these robots in games, and sometimes we actually do this in robots too. We actually purchase a cheap robot that we will learn. We will program up. We will teach the robot to do things for us. So, question number 3. Actually, is there a question in the? I think there's a question here about any STEM classes during the winter break. And I think Andy will be able to answer that. But yes, we do have. We will be having courses during the winter break, and so I can speak for myself here. We're planning to offer courses on machine learning and AI in December that will kind of go over the winter break, and then maybe other courses as well that might be of interest to folks. So I hope that answers your question, Alexandra. So winter camps or research opportunities in computer science. Yes, I think that there's a great degree of overlap between this question and the previous question here from Alexandra. So we have different programs that we offer, and I guess if you get in touch with Andy here or any of us here, we can point you in the right direction. And as I mentioned earlier on, we have a variety of courses that we're offering, and we like to think that these courses kind of build on each other. So, for example, you might start off by taking the programming course just to get familiar up to speed with programming. Then you might say, well, my mathematical skills are a little bit rusty, or I haven't done calculus yet. How can I refresh those? So again, we can we offer programs to help you get through that. In addition, we have a program on entrepreneurship and communication, and this is kind of, I think, really important to. We have we have foundational courses, and then we have next level up. So Python for data science and AI is maybe next level up, and then we have destination courses such as machine learning for artificial intelligence, where we really take it upon ourselves to move fast in a machine learning type context and build up really exciting applications of these areas. And then we have maybe very focused courses where we say, look, we're going to build, we're going to use AI to solve gaming problems. So I hope that those are those answers are clear, and if you have other questions, by all means, share them here in the chat. So does anybody want to maybe open their mic and maybe have a comment or question? Just verbalize it as opposed to typing it. No pressure. Pressure is for tires, as we say. So feel free to. So regardless, if you have other questions, please share them with Andy. So I think if you raise your hand, we can open the mic for you. Is that right, Andy?
Yes.
So if you have a question.
Allison, can you go ahead and open the floor so that they can use their mics?
I know that we're about 18 months into the pandemic and we're all Zoom experts, but sometimes it's nice to be able to hear people and see people, and so I hope that I find it's sometimes I feel like I'm just talking to myself, but I know that there's an audience out there, and it's nice to engage verbally and visually if possible.
And to answer the question, Andy, yes, I can allow them to talk once they raise their hand.
Okay, so the anonymous attendee that said we can't open the mic because this is a webinar, you just need to click the raise your hand button, and then James can answer your question. So if you want to talk, click the raise your hand button, please.
So regardless, well, I guess I want to say thank you for listening, and I hope you found this useful, and I hope that you find your passion, and we're here to help you in any way. And so if you reach out to Andy or anybody on the team here, or myself even, we'd be more than happy to tell you more about what might be useful for you in realizing your dreams. Okay. So Andy, thank you.
Sure. Helen has a question about contact info. We have a couple of different.
And I can just paste my email in here as well.
Yes. Do you want to talk with James directly? Inquiry by the email address he's going to send here to the chat. Otherwise, you can also contact me. I'll send my email address to the chat too. Both are perfectly fine. As far as our upcoming STEM course offerings and broader winter and spring course offerings, they are to be determined, but please stay tuned. We will be sending newsletters out here over the next weeks with more details. If you have an idea for a course, or you are hoping to get something together for some classmates, also feel free to reach out to us directly. We try our best to offer customized course offerings where possible, and be sure to follow us on WeChat. And if you have any questions, we still have a few minutes here. Any other questions?
Just wanted to get a sense if people could share where they're calling in from today. Are they on the west coast of the US? Are they in the US, outside the US? Maybe some kind of just a sense there. Maybe you can type in the chat. Maybe I'm calling in from Boston. Okay, great, awesome. I guess it's kind of late in the evening there. Okay, so I think that Andy can get in touch with you regarding costs and San Jose. Well done, welcome. Any other? These are all fun, exciting places to be. San Jose being the center of Silicon Valley. Boston is also a major center of technology. Other places, don't be shy, guys.
James, your question about the cost of each courses, I'll discuss with you directly after the webinar if you'd like. We don't have these details yet, but I can stay in touch with you about that.
So
I'll give you my WeChat address.
I'm Palo Alto, great. I'm based in San Francisco. So the course length, it varies, but typically we're looking at 5 to 7 weeks per course. And then it depends on, all right. So Andy, I think I will, if there are no other questions for me, I think that I will let Andy take over from here.
Okay, thank you very much.
Thank you, Andy. Thank you, everybody, for paying attention today. And I hope you got something from this. And hopefully we'll see you online here soon. Good luck, everybody, and happy Halloween.
Okay, so we have a few questions from the audience about the cost, the timeline, which classes we will be offering. All of these details are to be determined. However, you can directly reach out to me at my WeChat address if you'd like, or my email address. I'll also offer that into the chat here. And if you have any other questions, feel free to ask now. Otherwise, we'll wrap up this webinar here. Okay, looks like we don't have any other questions. Thank you for joining today, and we'll be in touch through our newsletters, through our WeChat articles, and through social media. And we'll be ready to answer your questions by email or by phone if you have anything you need to clarify. Our details about the STEM courses and other offerings will be going out in coming weeks. Thank you.